Hello, today is 11.7 of accelerated geometry, surface area of spheres. This is another cool thing we were going to do in class today if we had been in school. Every group was going to get an orange, and you were going to measure the great circle, the circumference of the great circle around the orange, and from that figure out what the radius of that great circle was, and then you were going to draw 6 circles on your paper. Then your next step was you were going to peel the orange and put the peelings into the circles to see how many circles were covered with those peelings. And what happens when you do that is there are 4 of the circles that get covered with the peelings. So if 4 of those circles, 1, 2, 3, 4, get covered with all the little peelings that you would peel off of that orange, then one of these has an area of pi r squared. This has an area of pi r squared. This has an area of pi r squared. This has an area of pi r squared. And so the surface area of a sphere would be 4 pi r squared. So that's a cool hands-on investigation that we were going to do to figure out that the surface area of a sphere is 4 pi r squared. If you had watched 11.6 simulation that I posted for the volume of a sphere, you would also have seen the next activity. So this one we wouldn't have done in class because I like the orange peeling one better. But this is kind of an interesting way to figure it out also, to figure out that the surface area of a sphere is 4 pi r squared. It says, in this investigation, we'll visualize a sphere's surface covered by tiny shapes that are nearly flat. So the surface area S of the sphere is the sum of the areas of all of the near polygons. If you imagine radii connecting each of the vertices of the near polygons to the center of the sphere, you are mentally dividing the volume of the sphere into many near pyramids. Each of the near pyramids is a base for a pyramid, and the radius r of the sphere is the height of the pyramid. So the volume V of the sphere is the sum of the volumes of all the pyramids. And that's what that investigation or that posting that I did, 11.6, I call it a simulation in my CMH, and I think on Teams it's just called Geometry 11.6. Now let's continue on here. So divide the surface of the sphere into these 1,000 near polygons with areas b sub 1, b sub 2, b sub 3, they go up to b sub 1,000. Imagine that there's 1,000 of these. Then you can write the surface area of the sphere as the sum of these 1,000 bases. The volume of the pyramid with base 1 is 1/3 times the area of the base, b sub 1, times the height of the object, which would be r. So the total volume of the sphere, V, is the sum of the volumes of these 1,000 pyramids. So here's the first pyramid, here's the volume of the second, blah, 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 all the way up to the volume of the 1,000th. So it says, now, what common expression can you factor from each of the terms on the right side? Well, I can factor out a 1/3 and an r, 1/3 and r. 1/3 and r from each of them. So that comes out to the front. And then I'm left with all these bases added up. All those bases added up is actually the surface area of the sphere. So it says, but the volume of the sphere is V equals 4/3 pi r cubed. Rewrite your equation from step 2 by substituting 4/3 pi r cubed for V and substituting for S the sum of the areas of all of the near polygons. So we're going to substitute this in as an S and this as the volume 4/3 pi r cubed. So here is that doing that. 4/3 pi r cubed equals 1/3 times the radius times S, which is the surface area. Okay, solve this equation. So what they did is they multiplied both sides by 3. So if they multiply both sides by 3, this cancels out. This cancels out. I get 4 pi r cubed is equal to rs. But then to get s alone, divide by r, divide by r. So there's s alone. And here I'll have 2 of those left. So there it is again. The surface area of a sphere is 4 pi r squared. So conjecture number 95 on your conjecture list, the surface area of a sphere is 4 pi r squared. And we have one example to illustrate this. Find the surface area of a sphere whose volume is given to me. So I said, first find the volume formula for a sphere to find its radius, then use the radius to find the surface area. Because, like here, I need, if I want to find the surface area of this, here's my 4, here's my pi, but I don't know the radius. And they don't tell me anything about the radius in the problem. So I go backwards and I say, oh, they do tell me something about the volume. So let's work with that. The volume is 4/3 pi r cubed. The volume is 1, 2, 3, 4, 8 pi. And I'm just substituting in that volume there. Okay, then to get rid of the 4/3, they multiply by 3/4. So that gets rid of this stuff. And here they put the 3/4 on this side. And then they divide by pi, so the pi's go away. So I now have this expression left equaling r cubed. So when I multiply 3/4 times 12,348, I get 9,261 is equal to r cubed. And then I take the cube root. And I can do that by 2 ways, taking the cube root of r cubed on this side, which would just be r, or taking r to the third and raising it to the 1/3 power. Either way, if I take the cube root of this side, I'd have to take the cube root of this side and use my calculator, or I could take 9261 and raise it to the 1/3 power. Either way I do that, I get an answer of 21 for r. So then, now I'm ready to put that into my surface area formula. So my radius I just found out is 21. 21 times 21 is 441. 4 times 441 is 1,764, and then there's still that pi there. You could leave that answer if you put in your calculator and round a little bit, you get 5,541.8 square meters for the surface area of a sphere. And that is the only example that they give in the book, and that's the only one I'll give you. So good luck with your problems. If you have questions, feel free to contact me.